Hello friends and welcome back to my channel. I have another course breakdown for you guys today. I am going to be covering another math course, this one in particular, linear algebra, because I have had a few people ask about it, and it's another first year course that we have, so we are in line with like how I've kind of been taking courses. So linear algebra is mathematics. Of course, it's algebra. So first I'm going to go through kind of the course outline, so like what we cover in my program. I'm gonna let you know which textbook we use, and then there was one question that I could find about it, and I'm also going to cover kind of some of my tips for trying to be successful in linear algebra. Trying to be successful. So the course outline, what we cover is vector geometry in R2 and R3, and when I say R2 and R3, it's like R to the superscript 2 and R to the superscript 3. So those would be real dimensions of numbers, I guess. It's been actually a long time since I did linear algebra, but one thing that I will say is that it's more abstract branch of math than any math that I had ever experienced prior. So like in high school, calculus and advanced functions and that kind of stuff is not as abstract as linear algebra is. So we also learned vector space R to the power of n, which is, as well as its subspaces, spanning sets, linear independence, bases and dimension, dot product in various dimensions, systems of linear equations and Gaussian, I don't know how to pronounce it, elimination. So just like some strategies with working with linear systems, matrices and matrix operations, matrix inverses as well. A matrix, I barely even knew what a matrix was when I started linear algebra, but it's basically like a grid of numbers. We also did matrix rank, so finding the rank of a matrix, linear transformations in various dimensions. We did introduction to determinants and Cramer's rule, introduction to eigenvalues, eigenvectors, and diagonalization of real matrices, and applications of linear algebra, so where it can be used in the real world, which is actually, linear algebra is one of the maths that I think is, I've seen more of it in my like further, in other computer classes than I have of like calculus and stuff. Linear algebra, yeah, is the math that I think has actually been the most helpful. So that, I know that outline is probably, if you have no introduction at all to linear algebra, that is a very confusing outline. Like everything in linear algebra, most concepts and like problem solving strategies we learned in linear algebra was brand new to me. So that's one thing. It's a very, as I mentioned, it's considered, I think, technically a branch of abstract math. So you probably haven't experienced that during high school. If you have, you're really lucky because it sets you up for this well. But there's a lot to look into. So the name of the textbook is Introduction to Linear Algebra for Science and Engineering. We used the second edition. So I guess my main tips for linear algebra is, once again, practice, practice, practice. But for linear algebra, it's almost more important to do that because I didn't necessarily find the concepts, like, yes, they were a little bit out there compared to other math that I had done before. All of the problems were pretty time consuming, I guess. So lots and lots and lots of formula memorization, because once you have those down pat and you understand how they work, literally all you have to do is sub in numbers. I kid you not, I make it sound maybe a little easier than it is, but yeah, lots and lots of practice really helped me with that. Even if you can wrap your head around the concepts, literally just memorize as much as possible and practice so that you get good at just muscle memory, plugging in the correct numbers, knowing how to solve each specific problem, obviously, which sounds like the same. It's kind of what you do for every math, I guess, but linear algebra was one of the ones that was so necessary. Like at the end of the day, there weren't really concepts that I understood, but if I didn't have those formulas memorized, then on an exam it would take longer for me to complete them, or I wouldn't quite know what to do next because I would like forget the next step. So that's so key for linear algebra. And then someone asked a question, which, do you solve systems of linear equations using Rref, which is reduced row echelon form? which sounds confusing if you've never done linear algebra, but it's basically a certain, you take a few steps to get the matrix that you're working with to a certain form, and from there it's very easy to like get certain characteristics from it. And then, so they asked if we get it to that form and then solve from there by hand. So yes, we do, which is like why I said it's very important to practice, because once you know how to get there, it's really not difficult and you can actually find what you're looking for and solve the problem pretty quickly. But you have to know, you have to be able to do that by hand. At least in my school you do, and I imagine it's the same in other schools. So you need to be pretty steady at it because it can be time consuming on exams. But they also asked if how big the numbers were to work with and how large of matrices we used. And because solving problems in linear algebra, especially an introduction to it, is so time consuming, my professor at least, thank God, bless his soul, made the numbers pretty easy to work with. So they were normally pretty friendly numbers and they were reasonable. And the whole point of the exams was to just show the professor that we knew how the process was supposed to work in order to find what he was asking for, not necessarily that we could keep track of a bunch of kind of ridiculous numbers, if that makes sense. And generally, if you understand the process for one dimension of matrix, you understand how it can be applied to higher dimensions. I know that this video is a little bit longer because I felt like there was quite a bit to cover for linear algebra, and I felt like it was a pretty important course to break down. So I'll try and leave the course outline in the description if I can remember to. But besides that, thank you guys so much for watching. Please leave any other questions that you have about courses in computer science down below, and I will try to include them in the appropriate videos for you. Thank you so much for watching. Don't forget to smile, and I will see you all in my next video. Bye.